Welcome to Pumping Python. My name is Jacob Itegboje, and this is one way to make a Python test-driven development environment. First requirement, if you do not already have it, then get Python. You can get that at python.org/downloads. There's a version for your operating system. For an integrated development environment, I will be using Visual Studio Code. You can get a copy at code.visualstudio.com/download. There's a version for your operating system. If you want a different integrated development environment, here's a list you can check out: wiki.python.org/moin/integrated development environments. Or you can do a search online for integrated development environments to see what's out there. If you have a Windows computer, then I suggest you install Linux using Windows Subsystem Linux. To do that, click Start on your keyboard or on the computer and type PowerShell, then right-click, select Run as Administrator, and in the terminal that opens up, type wsl-install. This will install the Ubuntu distribution of Linux. If you want a different distribution, say like Debian or something else, you do wsl-install --distribution and give the name of the distribution, so Debian in that case. Do not worry if you cannot install Windows Subsystem Linux, I have you covered. Time to write some code. I will open up a terminal here. If you have Linux, then do sudo apt update to update the package manager. And then sudo apt install. Now, when you first did sudo apt update, it might ask you for a password. Give the password, then do this part. And Python 3. Python 3-venv. Then --, yes. Run this and it will install Python 3 and the venv module, which I'll use to make a virtual environment later. I'm going to open up the Explorer here to show what happens as I type these commands. So imagine I'm working on a project called Magic. I'm going to make a folder for it that will contain all the things that relate to that project. I'll use the mkdir program to do that, give it the name Magic. Enter to run it, and now I have a Magic folder, but it is empty. To work in it, I'll go to it, change directory to Magic, so cd Magic. And I know I'm in the Magic folder when I see Magic on the left. Then I'll make another directory in here, mkdir source. This is going to hold the source code, the actual program that I'm working on. And then I'll add an empty file for the source code. I'll use the touch program, which makes an empty file with a name given. On Windows without Subsystem Linux, you'd use new -item to do the same thing. So touch source/magic.py. On Windows without Subsystem Linux, new -item source/magic.py. I now have a source folder inside the Magic folder, and there's a magic.py file in my source folder. The py here shows that this is a Python module. Next, I will make a directory for the tests. Then add a file to it, touch test/__init__.py. On Windows without Subsystem Linux, new -item test/__init__.py. And now in the Magic folder, I have a source folder with a file. I have a test folder with an init.py. This init.py tells Python that the test folder is a package, so it can find tests later. Now I'll add my test file, touch test/test_magic.py. On Windows without subsystem Linux, new -item test/test_magic.py. You can use any name for the file, just make sure it says test underscore here. This is going to hold the actual test file. The test-driven development cycle is Red-Green-Refactor. You can think of it as red, make it fail, green, make it pass, and refactor, make it better. To make it fail, I will write a failing test to make sure that the test works. To make it pass, I'll write only the code that is needed to make the failing test pass. And to make it better, I will follow the do not repeat yourself principle, or as Ken Beck is quoted as saying, remove duplication. This is the red part. Import unit test. Unit test is a module from the Python standard library that is used for testing. Enter 3 times, add class, test, magic, parentheses, a colon at the end. Class is the Python keyword for making classes, which are a collection of attributes and methods that have a purpose or for a particular purpose. The name of this one is test magic, and you can use any name, just make sure it has test in front of the name. It's written in cap words to follow Python's convention for naming classes. In the parentheses, I'll put unittest.testCase. Test case is a class in the unit test module that is used for testing. I will use one of its methods in a little bit. Enter twice. Oh, before I can go on, this line here defines inheritance. So test magic inherits from unittest.testCase, which means it is a child of unittest.testCase or clone of it or a subclass. The important thing here is that test magic has access to the attributes and methods of unittest.testCase. Enter twice at the end of the line, add def test underscore failure, parentheses, a colon at the end. Def is the Python keyword for making functions and methods. A method is a function in a class. The name of this one is test failure, and just like with test magic, you can name it, you can choose any name or use any name, just make sure it has test underscore in front of it. In the parentheses here, I will add self. Self refers to the test magic class. This allows me to access things that belong to test magic and by extension unit test or test case. At the end of the line here, I'll hit enter and then say self dot. When I do that, this is basically saying test magic. If I didn't use self, I would have to do test magic parentheses dot or unit test dot test case parentheses dot. Self.assert false parentheses. Assert false is a method from the unittest.testCase class which checks if its given input is false. I'll give it true, expecting that the test will fail because true is not false. And I am ready to run this test, but first I'll go up here to File and turn on the autosave feature to make sure that my files automatically save when I make a change. That way I do not repeat myself by having to manually save a file every time there's a change. To run the test, I'll go back to the terminal, type Python 3. On Windows without subsystem Linux, remove the 3. -m, this is the module option that takes a module name and Python runs it as a script. Give it unit test. Enter to run it, and it shows a message. If you're typing along, congratulations, you just wrote a test. This message is important, it shows a failure, and I like to read them from the bottom up. Here it says failed, the number of failures. It shows the number of tests run and how long it took. Then an exception and the message that came with the exception. In this case, the exception is an assertion error. The message is true is not false. I recommend keeping a list of exceptions you encounter. This will help you become more familiar with them, which will help you with troubleshooting because there's a lot of failure in programming. So I'll go up to the file here, enter 3 times, backspace, backspace, hashtag exceptions encountered. Then hashtag assertion error. Above the exception is the line that caused the failure. Then above that is the location of the failure. First, the file. It happened in testmagic.py, in the test folder, in the magic folder. It happened on line 7 in the test failure method. This path is a link. So if I hold Option or Control if you have a Windows keyboard and click on the file here, it will open the file in the editor and place the cursor at the line where the failure happened. Above that line is a header. It says traceback most recent call last. The stuff that's indented to the right here after traceback shows the calls that were made to lead to the failure. In this case, there was just one call. In some cases, there'll be many calls. And then above all of that is a header. It says fail, the name of the method, and in parentheses using dot notation, the location of that method. So here, test is the test folder. And this is one of the reasons why the init.py was added earlier. TestMagic is testmagic.py. And TestMagic in cap words is the class. Test failure is the method. I'm going to change true to false. And my expectation now is that the test passes because false is false. So back in the terminal, Python 3. On Windows without subsystem Linux, remove the 3. -m. The module option and give it unit test. Enter to run it. It shows a passing test. Cue celebration music and dance. I am green. How can I make this better? I ran Python 3-m unit test to see the test fail. And then I made a code change and ran it again to see the test pass. This means that if I make another code change, I'm going to have to run it again. One, to make sure that the previous test that was passing doesn't fail, and that the new code I added does what I expect. I do not want to type this again because it's going to be typed for every step of the test-driven development cycle or every time there's a code change. It would be better if a program runs the test when there's a code change. To do this, I'm going to use pytest-watch. This is a program that will watch the directory, and anytime a Python file in the directory changes, it will run pytest. Pytest is a program like unittest that is used for testing. Here's how to do that. First, I will make a virtual environment, Python 3-m. On Windows without subsystem Linux, remove the 3. Then venv, this is a module that makes a virtual environment with a name given. Give it .venv as the name. You can use any name. This is the name I'm using. Enter to run it. And now in the magic folder, I have a folder for my virtual environment, a folder for the source code, and a folder for the tests. And all of that is inside the magic folder that's separate from the rest of the computer. So things are kept in their own place away from other things. To use the virtual environment, I have to activate it. There's a script to do that. If you have Windows without subsystem Linux, you have to change the execution policy to allow remote scripts if you have not already done this. You do that by first launching PowerShell, running it as administrator, so you'd have a new terminal, and then type set-execution policy. And then give it remote signed as the execution policy you want. It will give you a warning about the security risks of changing your execution policy. We're changing the execution policy to remote signed, which means that it should allow scripts that come from a remote location if the publisher is verified. In this case, the script was written by the Python the guys who wrote Python, so we know that it's verified. Enter to run it, and then say yes to accept to confirm that it should change your execution policy. Then you can close that PowerShell window, go back to the one you were working in, and type .venv/scripts/activate.ps1. For the other operating systems, it will be source.venv/bin/activate. I know I'm in the virtual environment when I see the name in the left-hand corner. Then I'm going to upgrade Python's package manager to the latest version. I do that by calling Python 3. On Windows without subsystem Linux, remove the 3, -m, pip install. So call pip with the install argument. Pip is a module from the Python standard library that is used to install packages, to install Python packages. Give it the upgrade option and pip as the package name. Enter to run it. It will uninstall the version of pip that came with the virtual environment, download a new version, and install that new version. And then I'm going to make a requirements file. So echo pytest-watch. A greater than. First, echo is a program that displays its argument to the standard output. But I want this argument, this text, to be written to a file. So I will add a greater than sign and requirements.txt as the name of the file. You can use any name. Now I have a requirements.txt file with pytest-watch as its contents. On Windows without subsystem Linux, you do double quotes pytest-watch. Then a pipe out-file requirements.txt -encoding UTF-8. This does the same thing and makes a requirements.txt file that has pytest-watch as its text. And then to install pytest-watch, I'll do Python 3 on Windows without subsystem Linux, remove the 3, -m, and pip with the install argument again, -- requirements this time as the option, which takes the file name requirements.txt. Enter to run it. It downloads pytest-watch and its dependencies and installs them. So now I have pytest-watch, I have pytest and a bunch of other things, and I can run the tests now. The structure of this project makes it so that if I want to package things to send to someone, I can send the entire folder minus the venv folder. I don't need to send the virtual environment because this could get big. I could just send the requirements.txt, and the person I send it to can make their own virtual environment, install the dependencies from the requirements.txt file. This file will take any names I put in here, and I can even add versions if I want them to use specific versions. The test folder is also optional. If I want to, depending on how big it is, if I want them to be able to test, I can send it as well. And as stated earlier, I have the source code in a source folder. Okay, time to run the test. pytest-watch. Enter to run it, and it shows one passing test. And the name of the file here, test/testmagic.py. If I hold down Option or Control and click on the file, It opens it in the editor. I'm going to change false to true here. And it reacts to my change. It shows a failure, shows the name of the class, the name of the method. It has self here and explains what it is in a way. So test.testMagic.testMagic in cap words, and the test method, which is test failure, the line that caused the failure, the exception, the message that came with the exception, the path to the file, the line number, the exception, and a summary. It failed. It shows the test, the name of the file, the name of the class, the name of the method, the exception, and its message. And just like before, if I Option or Control click on the file name here, it opens it in the editor, places the cursor at the line where the failure happened, and I will hit end on the keyboard, change true to false. And the test passes, showing green, allowing me to go about the business of writing the rest of the code for the Magic project. You made it this far and have become the greatest programmer in the world. In keeping with the do not repeat yourself principle, I would write a program that has all the steps it took to get to this point. That way, when I want to make a Python test-driven development environment for a project, I can just call that program and I do not have to remember each step. Here's how to do that. First, to exit the test, I'll hit Ctrl-C on the keyboard. And then leave the virtual environment by typing deactivate. And leave the magic folder by typing cd ... Here means the parent, so I want to go to the pumping Python folder. In here, I'll make a new file called the touch program and the name of the program will be makepython_tdd.sh. On Windows without subsystem Linux, new -item make python tdd.ps1. The sh here shows that this is a shell program, and ps1 here shows that this is a PowerShell program. I'm going to make the PowerShell one as well so that I can show the code that goes in there. You can use any name for this program. Just make sure it's a name that describes what the program does, so that you remember when you see it later, or you know without looking at the code exactly what it does just by looking at the name. Make python tdd.sh. First, hashtag and an exclamation point. This is called the shebang line. It tells the computer what program to use to run the commands that are in here. I'll give it /bin/bash. So the computer will use bash to run the commands here. If you have Z shell installed like I do, you can change bash to zsh. Then I'll move the terminal to the right side. Right click on it, panel position, and right. I'm going to close the Explorer so I have some more space. In the terminal, type history. This will show the list of commands that I took to get here. So I want everything from mkdir-magic up to pytest-watch. Enter here mkdir-magic. Then cd-magic. mkdir source. Touch source/magic.py. mkdir tests. Touch tests /_init__.py. Then touch tests /test_magic.py. Python 3 -m venv.venv. source.venv /bin/activate. Then python 3 -m pip install --upgrade pip. Echo pytest-watch greater than sign requirements.txt. Then python 3 -m pip install --requirement requirements.txt. Then pytest-watch. I want to add the code that goes in testmagic.py, so enter here, enter after it, and move the terminal back to the bottom. I'm going to move testmagic.py here to the right side of the editor. Close out the terminal so I have more space. So everything in here is going to go into testmagic.py. To do that, I will change touch to echo, add quotes, and a greater than sign. Enter in between the quotes, then add import unit test. Enter 3 times class test magic parentheses a colon at the end. In the parentheses, add unittest.test case. Enter twice tab def test underscore failure parentheses a colon at the end. In the parentheses, add self. Enter tab self.assert false parentheses. In the parentheses, add true so the test fails. Enter 3 times backspace backspace hashtag exceptions encountered. Enter hashtag assertion error. All right. The problem with this program is it will always make the magic project. For it to take a name and make a project by the name I give it, or with the name I give it, I will hit enter here, then add a variable. In all caps, project underscore name. Equal sign $1. $1 here represents the first argument given when the project, $1 here represents the name of the project when the program is called. And then I'll replace magic with project name. So double click on magic and use find and replace. Option Command F or Control H, and then replace it with $project underscore name. Replace all. Okay, one last step to make this useful. I have to make it executable. To do that, I'll call the chmod program. chmod changes the mode of a file that it is given. I'll give it the +X option here, which says make the file executable. So give it make python tdd.sh. Enter to run it, and it is good to go. Make python tdd.ps1. First, $project underscore name equal sign $args square bracket 0. $arg square bracket 0 represents the first argument given when the program is called. Enter here mkdir $project underscore name. cd $project name. mkdir source. New -item. Double quote source / $project underscore name.py. Enter mkdir tests. The new -item. Test / init__.py. Enter twice, double quotes, a pipe, and out-file. Double quotes, test / test $, project underscore name.py. Hyphen encoding. UTF-8. And in between the double quotes here, I'm going to add the code for the file. This works just the same as with echo here and the greater than sign to write the contents to this test file. Import unit test. Enter 3 times class test $project underscore name parentheses a colon at the end. Put the $project name in parentheses and a $sign to the left of the parentheses. In the parentheses, add unittest.testCase. Enter twice tab def test underscore failure parentheses a colon at the end. In the parentheses, add self. Enter tab self.assert false parentheses. In the parentheses, put true to see the test fail. Enter 3 times backspace hashtag exceptions encountered. Enter hashtag assertion error. Then go down to the end of the file, enter twice, add python -m venv.venv .venv /scripts /activate.ps1 Python-m pip install --upgrade pip. Then double quotes pytest-watch. A pipe out -file requirements.txt -encoding UTF-8 in all caps. Then Python-m pip install requirements.txt. Then pytest-watch. All right, to use this, it would be /make python tdd.ps1 and let's say I was working on the how to make a calculator project. I'll give it calculator as the name. Then run it. On my computer, I have 3 folders here, and for the other operating systems, it will be /make python tdd.sh. Give the name calculator. Enter to run it, and now I have an extra folder named calculator, and there's some activity happening in the terminal. It's installing stuff, then it runs the test. In the calculator folder, I have a folder for my virtual environment. I have a source folder with the name of the project.py. I have a test folder with an init.py and test underscore the name of the project.py. I have a requirements.txt file with pytest-watch as its text. In the terminal, it shows me a failure, test calculator.test failure, self test.test calculator.test calculator. The test method is test failure. The line that caused the failure, as expected, because true is not false. It shows the exception and its message, shows the path to the file and the line number where the failure happened. Shows the exception and a summary. And like before, when I option or control click on the path here, it opens it in the terminal with the cursor at the line where the failure happened. I'll change true to false to make it pass. And the terminal shows the test is passing. I am green, allowing me to go about the business of writing the rest of the code for the calculator. For example, here there's a warning from the code spell checker about the name of the class because the C here is a small letter. When I change it to a capital letter, the warning goes away, the terminal runs the test again, and I am still passing. One of the advantages of programming is I can take some steps and make them a one-line command that the computer does for me. You have seen one way to make a Python test-driven development environment and have a program to do it anytime you want on a Linux, a Windows, or macOS computer. Would you like to test how to make a calculator? I will see you in the next one.